Ever wondered how computers communicate, how they send and receive data? Well, it's all thanks to the magic of networking. Networking is the backbone of information technology, enabling computers to exchange information seamlessly. It's like the highway system of the digital world, allowing data to travel from one point to another. It's not just about connecting computers, but about creating a system for effective and efficient communication. So, are you ready to explore this digital highway system? Now let's dive deeper into the world of networking. To understand how computers communicate, you need to know about the OSI model. This clever acronym stands for Open Systems Interconnection, a model that breaks down the complex process of computer communication into 7 manageable layers. Starting from the bottom, we have the physical layer. This is where the rubber meets the road, or rather where the data meets the cable. It's all about the physical aspects of data transmission: cables, connectors, voltages. Next up is the data link layer, which is responsible for getting data across the physical network. It's kind of like a traffic cop, directing packets of data so they don't collide. The third layer is the network layer. This is where things start to get exciting. The network layer is responsible for finding the best path for data to travel from point A to point B. Moving on, we reach the transport layer. This layer ensures that data is delivered error-free, in sequence, and with no losses or duplications. It's like the reliable postman of the network. The session layer, the 5th in our lineup, sets up, coordinates, and terminates conversations between applications. It's the party planner of the network world. Next, we have the presentation layer. This layer translates the data from the application into a format that the network can understand, and vice versa. Think of it as a translator. Finally, at the top, we have the application layer. This is where you, the user, interact with the software application. It's the layer you're probably most familiar with. With the OSI model, we can see how different layers work together to provide network services. IP addresses are like the phone numbers of the internet. Think about it. When you dial a phone number, you're reaching a specific person or place. Similarly, IP addresses are unique identifiers that allow computers to find and communicate with each other on a network. It's like each device on the network has its own unique phone number. But here's where it gets interesting. Just as phone numbers are divided into country codes, area codes, and local numbers, IP addresses are divided into subnets. This division allows for better management and organization of IP addresses within a network. Imagine a large office building. Without a system of suite numbers or subnets, finding the right office would be a nightmare. But with suite numbers, you can easily find where you need to go. Similarly, subnets help manage network traffic, ensuring that data packets reach their correct destination efficiently. With an understanding of IP addresses and subnets, you can better manage network traffic. Protocols are the rules of communication. They are the backbone of networking, establishing how data should be sent, received, and interpreted. There are several common networking protocols, each serving a unique purpose. Let's briefly touch on a few of them. First up is TCP, or Transmission Control Protocol. This guy ensures the data arrives in the right order and without errors. It's like a meticulous organizer, making sure everything is in its right place. Next is UDP, the User Datagram Protocol. Unlike TCP, UDP doesn't guarantee delivery or order, but it's quicker because it skips the checks. It's like the fast and loose courier of the networking world. Then there's ICMP, the Internet Control Message Protocol. This one helps manage errors and operational information. Think of it as the troubleshooter, always ready to pinpoint issues and keep things running smoothly. By following these protocols, computers can communicate effectively and securely. Remember, each protocol plays a crucial role in the grand scheme of networking. Now, how can you check which ports are open on a machine? That's where port scanning tools come into play. These are essential parts of the networking toolkit, helping us identify open ports that could potentially be exploited by malicious actors. Let's dive into 2 popular tools, Nmap and Mascan. Nmap, which stands for Network Mapper, is a powerful, flexible, and reliable tool used for network discovery and security auditing. With Nmap, you can detect open ports, identify what services are running on them, and even determine what operating system a machine is running. On the other hand, Mascan is touted as the fastest internet port scanner. It can scan the entire internet in under 6 minutes. However, it's not as feature-rich as Nmap, so it's often used for quick, broad scans before diving in deeper with a tool like Nmap. With tools like Nmap and Mascan, you can ensure your network remains secure. So we've covered a lot today. From the layers of the OSI model that form the backbone of network communication to the intricacies of IP addresses and subnets. We've navigated through common networking protocols like TCP, UDP, and ICMP, and even delved into the realm of port scanning tools like Nmap and Mascan. Each piece in this complex puzzle of networking plays a crucial role. With these basics, you're well on your way to understanding the fascinating world of networking